I feel a little underdressed today because I actually work at MIT Science Department. So, I do like to. Yeah. I'm actually next time. What I was going to say is that one time I did wear a blazer the other day, and people started looking at me very worried, and they're like, "Why are you wearing that? Is Google here? Do you have an interview?" And I'm like, "No, I just wanted to wear this." So I think I've unlearned how to be presentable in some sense. So anyway, I'm going to talk today about this project I've been working on and working on in conjunction with CGA for the last year. Has been described. MAPD, it's an acronym for Massively Parallel Database. Using GPUs for real-time querying and visualization of big data. And I'd like to add analysis to that as well. And more of that's coming. So, can you hear me? Okay. So let me tell you a little bit first, like what made me want to build such a system. I'm actually not a computer scientist by background, even though I work at I'm a researcher in the computer science department at MIT. But I did my master's here at Harvard in Middle Eastern Studies. So for my master's thesis, I basically wanted to see, I had a bunch of tweets that I had harvested from Egypt. And I wanted to see if there was any correlation between the level of like political Islamism in different parts of Egypt and income levels, basically, this old idea that is Islamism associated with poverty. So what I did is I scored each of these tweets for political Islamism on 3 different measures. The number of Muslim Brotherhood politicians followed, discursive similarity to Islamist forum posts, and did the tweeters stop tweeting at 5 daily prayer times. I spatially joined those with 5,000 census districts, which took forever, by the way, in PostGIS. You can basically, if you're lucky, you can do about 10,000 polygons a second, which means it takes many hours to do 40 million or 100 million. I regressed these scores against variables for urbanization and SES. And I think we should take this with a grain of salt because Twitter is not necessarily representative, but I found that Islamism was not associated with income, but was associated with rurality. And so it took hundreds of hours of computation on my pretty beefy home computer, which is 6 cores and 64 gigs of memory. Weeks of programming. What if somebody wanted to do this kind of analysis, basically regressing point data by census data, but they wanted to do it in milliseconds, so they could enable real-time analysis? So enter MAPD. So I started building this system. It runs on graphics cards, on GPUs. You know what people play, like, they don't play Doom or Quake anymore. They play like Call of Duty or something. The nice things is that these GPUs have tons and tons of processors and do stuff like database and GIS stuff really fast. So it's a real-time map generator. It can do point, heat maps. Now it can do polygons, lines. I'm trying to build it into more of a general-purpose GIS platform. It's a WMS web server, so you can just take your OpenLayers client right out of the box and request maps from it. And so you get this ultra-high-speed platform put into a browser. And it's fast and cost-effective. Our system that we use here, we have 4 NVIDIA 680 GPUs, $600 each. It gives us 12 teraflops of, you may or may not know what that is, but it's a lot. So it's a really fast system. So here's some just some pretty pictures. That's New York, tweets in New York. It picks up places very well. This is percentage of tweets that contain the word Central Park. You can see how it outlines people tweet that they're in Central Park when they're in Central Park. Okay, so you ever remember like Home Improvement with Tim the Toolman Taylor? This is where I want to kind of go, like, the R. Like when I see this, the card on the left, it's just amazing that this amount of compute power can be packed in something that costs $1,000, requires 2.5 light bulbs of electricity. It's 10 inches by 4 inches, and it's equal in speed, just one of these, to the fastest supercomputer in June 2000. That's the ASCI Red. That was also 1.3 teraflops, trillion calculations per second. But that thing took up 1,600 square feet, 850 kilowatts, so 850,000 light bulbs, and cost $72.4 million. So we've come a long way. Some of that is Moore's Law, but a lot of it is just the revolution that GPUs have brought to compute technology. People just aren't just using them for graphics. They're really powerful computing platforms. So this is just a little more detail. comparing a typical processor with an NVIDIA 680. I'm actually not going to get into this in the interest of time, but basically you get much higher performance per cost and higher performance per watt ratio. So instead of running a big cluster of MapReduce, people do like 100 computers, you can just have one server and do it on 4 graphics cards. The basic database architecture is you have any number of GPUs. You have a main memory buffer pool, which the data is stored both on the GPU and in the main memory. So it's not just the graphics that are being done on the GPU. The full SQL query is being executed on the GPU. And that's why you can search against a billion tweets in 5 milliseconds, like super fast. I have this system where I store words as primes. That allows me to compress the text. I won't get into this too much, except that I'll put a white paper out later if anybody's interested. This is just a quick benchmark. This is actually a very conservative one. This is me doing something optimized on the computer, no hard disk, and we got 70x. If you were like doing something that involved hard disk, it would be like 500x. Or if you were doing something like rendering heat maps, it's like 500x. Use cases for MapD, you can think of a lot of them. Right now we're working with some researchers from Mass General Hospital about building a flu tracking platform, because there's Google flu trends, but it doesn't quite have like the temporal and spatial granularity that Twitter does. Here you can see an outbreak in the southern United States. This cluster of tweets around the south, and you can see that line graph going up. This big one that I want to do is regression, as I said, against census variables. So you can imagine, what is the sentiment towards some politician regressed by income, or regressed by unemployment rate, or regressed by doing all this on the fly? Or where do people drink Coke versus Pepsi against various demographic variables? Trend detection, I'm working on this, being able to see, not just in the current time, but over all space and time, what people were talking about at a certain time. And that will just pop up words over the map. So that's going to be a cool feature. Graph analysis, basically networks of, say, Twitterers or Facebook people. Very useful. Machine learning. GPUs are awesome for machine learning. I'm building some of that functionality. Or just an ultra-fast database. You don't even need to have spatial data. You can just use this as a really, really fast database. So what's next? I'm rewriting the base, the code base. Some of the stuff that I said in the last slide. One big thing is I'm trying to figure out what's the right, I would like to open source this, and I'm going to be doing an open source release, but I'd also probably like to commercialize it in some way, kind of like Tengen and MongoDB, if you know that. I haven't quite decided on exactly my route I'm going to take, but hopefully you'll know more in a few months. Okay, so how are we doing on time? We have a minute or two? Okay. So I am going to just give you a quick real-time demo, and then I'm going to show a few videos, because I'm not just, so this is just tweets, so you can see the speed of the system here. But also I wanted to show you, so we can type in, we're searching for like text, like marathon. You can see the spike in tweets about marathon. You can animate it. This is my own interface. Some of these features will be brought into World Maps interface. We can also do mass road segments. So I'm trying to work on. So this is all being rendered on the fly. None of this is pre-cached. Census blocks. Oops. Okay, I don't know why. Oh, I do know why. I don't have the census blocks, but I have all the census blocks on here. But they're not currently on this system. So I'm going to show you a few just quick videos. So I'm going to skip over some of this. I'm just going to show you this animation I did for marathon over the whole country. And it's kind of cool to see how the news spreads about the bombing. You can see people are talking about the marathon, and then boom. So that's when the news spreads outwards from Boston. You can do other interesting things. You can track people's drinking, I can't. Well, I can't get the play button. Let's see. That's unfortunate.
You can't resize the window.
I'm not like used to Windows,
Yeah.
unfortunately.
Click on view.
Fit the screen. Okay, there we go. So this is just cutting coffee. Like you can see it spread from east to west. And then finally, since the subject of this conference is privacy, there are some important issues to think about, like with Twitter data or any other locational data. Like this one guy, you know, I can search just by user. So I found this one guy on a boat and just cruising down the Caribbean. And he was just saying, hey, it's windy out here. You can see him traveling along. You know, and then this other, one last one, and then I'll be done. Oops. Oh, I don't believe I have it on here. Okay, I'll show one other interesting one. This is tweets about church. So you can see the huge spikes, and it's also very southern-centric on Sunday. So there's a lot of interesting, fun and interesting possible applications of this. All right.
Thanks, Todd.
Great.
We'll maybe show some videos if you have a couple more after.
Sure, there's some YouTube stuff
Yeah,
up there.
it's fun to play with.